Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll do the integral of minus x squared minus 2x plus 3 dx. And the technique that I will use is the completion of a perfect square, the trigonometric identities, and integration by trigonometric substitution. Just as a reminder, when can we use trigonometric substitution? If I have square root of a squared minus x squared, I can take my x is equal to a sine x, and I will be using the trigonometric identity formula 1 minus sine x squared equal cosine square of x. And if I have square root of a squared plus x squared, I will use my x equal a tan of x, and I will use the trigonometric substitution, the trigonometric identity formula 1 plus tan square of x is equals x square of x. And if I have x square, x squared plus a square, I will take my x is equal a sec of theta, and I will use the trigonometric identity formula 1 minus sec square of theta is equal to tan square of theta. So let's see how we're gonna jump from that integral to something that will look like one of those three formula. If I look at my integral, I know that x plus 1 square is equal x squared plus 2x plus 1. And I see x squared plus 2x. All what I have to do is to add 1 and subtract 1 to that integral and change the minus here. I need them to be plus x squared plus 2x plus 1. So let's start and you will see how I will do it. So the integral of square root here, if I can factor out a minus, I will have x squared plus 2x, and instead of plus 3 it will be minus 3, which is, this is the starting of x squared plus 2x. I need to add 1, subtract 1 to it. So my integral becomes square root of minus x squared plus 2x plus 1. Minus 1 minus 3 is minus 4 dx. Perfect. So now my integral become minus x plus 1 squared, and minus times minus is plus 4 dx. But I wanted a square minus x square, and this is a variable. This is my x and this is my a. So I will rewrite it as a square minus x square. It become my a square is 4 minus x plus 1 square dx. Now I know that 4 is a perfect square and x plus 1 square is a perfect square. So my 4 is my a square, and the x minus 1 is my x square. X minus 1 square is my x square. So I will say let x equal a, which is 2 in that case, because a square is equal to 4, so a is equal to, well, I need x plus 1. I don't need x, so I put here x plus 1 equal x plus 1 equal 2 sine of theta, because we said we take a x equal a sine of theta. Here I have x plus 1, so I took x plus 1 is equal my a, which is 2 sine of theta. And I know that I will be using the trigonometric identity 1 minus sine square of theta is equal to cosine square of theta. So if x plus 1 equal 2 sine of theta, so dx is equal to cosine of theta d theta, because the derivative of sine theta is cosine theta. And the 2 is a constant, we keep it. So I can rewrite my integral as square root of 4 minus, instead of x plus 1, I replace x plus 1 by its value, which is 2 sine of theta square. And my dx, I replace it by 2 cosine theta d theta. Now we use the trigonometric substitution to have a trigonometric integral. Now I have 2 sine theta square. Let's make it square. So it is square root of 4 minus 4 sine square of theta multiplied by 2 cosine of theta d theta. I can factor out my 4 here. It becomes 4, 1 minus sine square of theta, multiplied by 2 cosine of theta d theta. But the 2 is a constant. I can put it outside and take it from my integral to facilitate my life. And I know now, because I have multiplication, 4 multiplied by the parentheses, so I can take the 4 outside my square root, it become 2. So the 4 here would go as 2, and the 2 would go here. I will have 4 integral of square root 1 minus sine square of theta times cosine of theta d theta. And you remember I told you we will use 1 minus sine square of theta here is equal to cosine square of theta. So I have 1 minus square of theta. I will use the formula that we knew that we had to use, which is square root of cosine square of theta multiplied by cosine of theta d theta. But square root of cosine square of theta is cos of theta, and cos times cos is cosine square. So my integral become 4 integral of cos square of theta d theta. And here I will use trigonometric identity formula that said cos of 2 theta is equal to cos square of theta plus minus 1. Perfect. So if I want to isolate my cos square of theta, I will have cos 2 theta plus 1 equal to cos square of theta. I divide here by 2 and I divide here by 2. That 2 and that 2 would go out. So cos square of theta would be equal to cos of 2 theta plus 1 divided by 2. So I will replace that cos square of theta. So I'll put 4 integral. Well, instead of saying cos 2 theta plus 1, I will put 1 plus cos 2 of theta. You will see why. Plus cos 2 theta divided by 2 d theta. And because of this plus, I can divide my integral into 2 integral. So 4, and this 2 would go outside the integral, divided by 2 would go outside. Integral of 1 times d theta plus cos of integral of cos of 2 theta d theta. And 4 divided by 2 is 2. Integral of d theta is theta plus, here I can say let u equal to theta. So du is equal to d theta. So my d theta is equal du divided by 2. So my integral become cos of u multiplied. I have to multiply it by the 2 here, because the 2 is for this and for this integral. There is a 2 here. Du divided by 2. Du. So I replaced my d theta here by du divided by 2. This is my du divided by 2. So that 2 with that 2 would disappear. And I know integral of cos of u is sine of u. So I will have 2 theta plus sine. But instead of saying u, I will replace it by 2 theta plus c. And here there is another trigonometric identity that said sine of 2 theta. It's a trigonometric identity formula that said sine of 2 theta is equal at 2 sine of theta cosine of theta. I will use that. I will replace my sine of 2 theta by 2 sine of theta cosine of theta. So I will have 2 theta plus 2 sine of theta cosine of theta plus c. And that will be easy to solve now. If I write my famous trigonometric triangle, and that's my theta, and that's my right angle. And if you remember at the beginning, we said let x plus 1 equal to 2 sine of theta. Here. we took x plus 1 is equal to sine of theta, so I rewrite it here. X plus 1 is equal to sine of theta, so that means my sine of theta is equal x plus 1 divided by 2, but I know sine is equal to the opposite side divided by the hypotenuse. So the opposite side of theta should be x plus 1 and the hypotenuse should be equal to 2, and here I would have square root of 4 minus 4x here. 4 minus x plus 1 square. 4 minus x plus 1 square. But you remember the 4 minus x plus 1 square? The 4 minus x plus 1 square used to be that formula here. Or that formula. Minus x square minus 2x plus 3. So this is equal minus x square minus 2x plus 3. It is the same thing. If you develop this one, you will have this one. If you develop that, you will have this. So my solution was 2 theta plus 2 sine of theta cosine of theta plus c. Okay? We know sine of theta is equal to this. We know sine of theta is equal x plus 1 divided by 2. I know that cosine of theta is equal the adjacent, which is square root of minus x square minus 2x plus 3 divided by 2. And the theta is equal sine minus 1 of x plus 1 divided by 2. Because I have the sine theta equal x plus 1 divided by 2. So theta is equal to sine minus 1 of x plus 1 divided by 2. And I will replace them in that solution that I have. So I would have 2 times sine minus 1 or arc sine, the same thing. X plus 1 divided by 2 plus 2. And the sine of theta, I would write x plus 1 divided by 2 multiplied by the cosine of theta multiplied by square root of minus x square minus 2x plus 3 divided by 2 plus my c. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.